Okay, we're going to look at some problems here where we're going to be graphing some polynomials that are already in factored form. This is kind of leading into our bigger discussion of taking a polynomial and factoring it, but we're going to start here. So a couple of things. We want to identify the degree. And so if I were to expand all of this, we have an x to the third times an x. And since that's squared, we'd have two of those factors. So 3, 4, 5, 6. So our degree is a 6th degree. Our roots, so we take each factor and set it equal to 0. So if we took x cubed, set it equal to 0, we would get x equals 0. Because that's cubed, that's what we call a triple root. Here, we'd have 2 as a root, x equals 2, because 2 would make that factor 0. And because it's squared, that's a double root. And then our last one, if we took x plus 3, set it equal to 0, we would get x equals negative 3. And that is a single root because it is being raised to the first power. Okay, so here we have a root at 0, we have a root at 2, and we have a root at negative 3. Okay, because we have a root at 0, our y-intercept, if we substitute 0 for x, we're going to get 0 for y. So we have that point. And then lastly, what we want to do is our end behavior. I'll do that over here. We're going to use our limit notation for that. And in essence, what we're saying is, as our x values go to negative infinity, what do our y values do? And there's two things that determine that. One is our degree, whether it's odd or even. In this case, it is even. And then the leading coefficient, is it positive or negative? In this case, it's positive. So that means that when we combine those two, an even degree and a positive leading coefficient, as x were to go to negative infinity, our function would go to positive infinity, because you're going to have a negative number, like negative 1,000,000, raised to an even power, so that would be positive, and we're multiplying that times a leading coefficient, which is positive. And then the same on the other end. As we go to positive infinity, our function values would also go to positive infinity. And so this gives us a sense of where to start our graph. Here, on the left side, do we start up at positive or negative infinity? And where do we end it as we go up to positive infinity? So we're also going to end it here. So we're going to begin up here in our second quadrant, end up here in our first. And now we're going to be up here somewhere. And we're going to come down. And negative 3, it's a single root, so we pass through that similar to a linear equation. Somewhere down here we turn around. It doesn't really matter where. When we get up to 0, because it's a triple root, we have a little bit of what we call kind of like that S flattened out shape. And then we're going to go up, and we're going to come back down somewhere. And we don't know exactly where without some calculus. And at 2, we have a double root, so we would bounce off the x-axis and go back up again. So there our graph matches our end behavior. And again, exactly where this turns around, each of these, without some calculus, we really don't know. So we're fine with that shape. Okay, let's look at another problem here. We have g of x equals negative. So that's the same as having a negative 1 there. X minus 1 cubed and x plus 2 squared. Okay, so down here we're going to start off with what is our degree. So that's a third. That's squared, so that's going to be a 5th degree. For our roots, again, here we have 1, and that's a triple root. So x equals 1 is a triple root. And here we'd have negative 3, because that would make that factor 0, and that is a double root because it's being squared. And then for our y-intercept, because we like to have another point, make that accurate if we can. If I substitute 0 for x here, we're going to get 9. 0 minus 1 is negative 1 cubed is negative 1 times another negative 1. So we're going to end up with 0, 9 as our y-intercept. So here's 0, 9. We have 1 as a triple root and negative 3 as a double root. Okay, and then we're going to add our end behaviors so we know where to begin and end our graph. So first we look at what happens as x goes to negative infinity. So I have an odd degree. So if I took a negative number way down here to an odd power, that would be negative. But we're multiplying that times the negative leading coefficient. So that would be positive. So it's going to go to positive infinity. And one of the things that we should know now is with an odd degree polynomial, that we begin in opposite corner, so an end rather. So if we start here, we're going to end here. And similarly, if we took a positive number, since we're positive infinity, we're going to end down here. If we took a positive number, right, if we go off to infinity to an odd power, that's positive. Multiplying that by a negative leading coefficient would be negative. Okay, so we know we're going to start up here. Negative 3 is a double root, so we know we bounce off there. We're going to go up somewhere up to 9. I don't know exactly where, but I'll just turn around, try to make this a nice smooth curve. When we get to 1, it's going to be a triple root. So we have that S curve in there. And there we go down to negative infinity as x goes to positive infinity. All right, we're going to look at one more. In here, h of x, we have, let's see here. Oh, I copied the same one, so we're going to change that. I thought something looked a little strange there. All right, so we're going to make this negative 2 times x squared minus 2 times x plus 1 squared. Let me be a little neater there. Okay. So let's see. We're going to start off with our degree. So that's x squared, and that's going to be an x squared, so that makes this a fourth degree. Our roots, now here's something a little different. Right here, instead of having a linear factor squared, here in this parentheses we have x squared minus 2. So if we were to take x squared minus 2 and set it equal to 0, notice add 2, right, square root, there's our absolute value of x. And so we end up with both plus and minus radical 2. So we have two irrational roots here. So we have plus and minus. And those are both single roots. So one of the things you'll learn is that we could have written this, you'll see this come up soon, as x minus root 2 and x plus root 2. And then this factor will give us x equals negative 1 as a root. And because we're squaring, that will be a double root. And then we want to find our y-intercept. So we're going to substitute 0 for x. Well, that'll be 1 squared is 1. 0 squared is 0 minus 2 times another negative 2. So that would be 0, 4. Okay, so we have a y-intercept of 0, 4. We have a double root at negative 1. And now we're going to have to approximate square root of 2. If you think about the square root of 1 is 1, the square root of 4 is 2, so we're between 1 and 2. So I'm just going to approximate in there. And now we're going to do our end behavior. Again, using our limit notation. So I have a fourth degree, and anytime we take a even degree polynomial, we either begin and end here, or we begin and end here. We look at our leading coefficient, which is a negative 2. And so if we took a negative number to an even power, that would be positive, but now we're multiplying it by a negative. So it's going to be a negative number, and the same thing over here. If we took a positive to an even power times a negative, that's going to be negative. So for our end behavior, the limit as x approaches negative infinity of h of x is negative infinity, and the limit as x approaches positive infinity of h of x is also negative infinity. Okay, so we have a single root. This is a little tight in here, So we're going to come up through the single root at negative root 2. We've got to turn around and come down to our double root at negative 1, which means we bounce off. There's our y-intercept. We're going to come back down through our single root again at positive root 2. And notice then our end behavior matches. Even degree, both going either to negative or positive, in this case negative, because again our leading coefficient is a negative. So there's a complete graph given this function. Hope that helps, and we'll see you soon.